Hi guys, I just realized after recording this that this is a funny day. So have funny day, do whatever you want on this funny day. Um, use this funny day how you want. I just forgot to recognize it. But I'm putting this in at the beginning. This is one of my least favorite problems that I've ever done. I just really hate it because I hate law of cosine and sine. But I guess you guys will see how I do with it. Cool, thank you guys for watching. I will see you guys, or no, I guess you'll see the rest of the video. Um, have fun watching it. Bye. Hi guys. Okay, so right triangle ABC is area 120, hypotenuse length BC equals 21 or 29. Okay, so ABC, ABC is area 120, BC equals 20. So that means that AB times BC. No, this is not right. BC is the hypotenuse. So AB times AC, I guess it should be CA is equal to 240, 120 times 2. So we also know that AB plus AB squared plus AC squared is equal to 29 squared. Now we also know that DEF is another triangle. We don't know what it's shaped like at all, but we know that AC is equal to DF. So, and EF, so, wait, what? It'd be D, D, E, F. EF is 21. Um, and then the other two side lengths are equal to the ones in the right triangle. So it's really as if you took this right triangle, took one of the legs, and then just rotated it. Interesting. Okay. Um, so let's just find these two, I guess. We know AB is going to be equal to 240 over AC. So 240 over AC squared plus AC squared is equal to 29 squared. So if we take 240 squared plus, it's going to be AC to the negative 2, or times AC to the negative 2, plus AC squared is going to be equal to 29 squared. So 240 squared times, if we multiply by AC squared, we can cancel that out. And then we get plus AC to the 4, and then we could do minus 29 squared times AC squared is equal to 0. So then if we say what x is equal to AC squared, then we get x squared minus 24 squared x plus 240 is equal to 0. 240 squared. So our solution for x is going to be, can we factor this? Two things that multiply to 240 squared that add to negative, so they'd both be negative, so it'd be x minus something, x plus something. Well, the factors of this are going to be 240 squared is going to be 2 squared, 5 squared, or 2 times 5 times 240, which is 3 times 2 to the 3. So 2 to the 4, and then all these are squared, so it's going to be 2 to the 8, 2, 3. Okay. So if we, 2 to the 8 is the same thing as 2 to the 5 is 32, 2 to the 6 is 64, 2 to the 7 is 128, 2 to the 8 is 256. Okay, can we get these to add to 24 squared, which is... It's going to be 576. Wait, what did I just write? It's going to be 6, 5, it's going to be 7. Yeah, 576. Okay, 256. This is going to be 25 times 9 is 225. No. What if we swap? Is this too large or too small? It's going to be just too large. So if we do 2 to the 7 times 3 plus 5 squared times 3 times 2, so that's going to be 25 times 6 is 150. This one is going to be 1, 8. No, this is too small. Okay, where did I leave off? So I'm trying to find the area of this triangle here. Why is my something not plugged in? Why can't I? Alright, there we go. Trying to find the area of this triangle. Yeah. So what are we doing? We're trying to find the side lengths here. So we know that the area is 120 and the hypotenuse is 29. Okay, so a squared times this equals 29 squared. So then we got this quadratic. So we're gonna get, so we're looking for the solution to this quadratic. So two things that add up to 576 that multiply to 240 squared. Okay. So 240 squared, we have 256, 225, that would give us 481. So we need an even larger, so they need to be closer together. So can I think of a product of these that is close to like 250? Well, 576 over 2 is just going to be 250 plus 35 plus 3. So it's going to be 3 or 8, 8, 2. So something that's close to 288. Oh, can we just split this in half? 2 to the 4 times 5 times 3. 2 to the 4 is 16 times 5 is 80 times 3 is 240. So adding these two together, we get 480, which is not, which is interesting because we need it to be larger. Maybe I miscalculated 24 squared. No, I didn't. Is this truly correct? So it's 24 times 10 24 is 5 times 2 times 3 times 8. So, yeah, that seems correct. Hmm. What could I have done wrong? Oh, I'm just slow. This is 29 squared. Right? So that makes it even more unattainable because I need 29 squared, which is going to be even larger. Right? Or does that give me the minimum? No, it doesn't. 29 squared is... No. So 841. What? Two things that add up to 841. Well, I guess maybe... since it ends in 1, maybe it's like 81 something? What's 841? No, because we can't... 81 is not possible. Um... If we could do like 256 times 5, which is 1,280. No, that's too large. You could do 128 times 5, which is 500, 640, plus it'd be 2 times 5 times 3 squared, which is 90. No. We do 128 times 5 times 2, no. 128 times 5 times 3, no. 128 times 3 times something? No. We could do 64 times 5. I have a feeling this is not the way I'm supposed to be doing this. I have a feeling we need the sum of the side lengths or something. What's the way to find area again for any given... It's like AB cosine theta or something, I think. Wait, somebody... I'm not gonna get it if I don't know this, because I think this is what I need. Somebody added in a comment, so I'm gonna cheat, I'm gonna look at that. So, let's... I don't know if this is gonna count, but I'm just gonna look at that, because I'm not gonna get it otherwise. Hi guys, it's 1/2 cosine, or 1/2 AB sine theta. Oh shoot. Let me check its sign, because I genuinely forgot. Sine theta, and theta is the angle between... Yeah, 1/2 AB sine theta. So it's gonna be... Uh, if theta is... If we're doing these two side lengths, it has to be this theta. I don't know how we're gonna find this theta, though. I think it has to do with the fact, I mentioned this earlier today, that it's just this rotated. So theta is going to be, of course, less than 90, or less than pi over 2. but it's hard to know. Um, okay, so AB, if it's these two, we know AB is 240 squared. No, AB is 240. So it's 120 sine theta. So just need to find theta. If theta changes 29 to 21, what is... Oh, I swear I remember seeing like unit circle videos that are like this, and then this, and then like if you have this point here, it's this, or like also this or something. Maybe that's tangent. Or if you're changing the angle there. No, you don't want that. You want... Hmm. It's gonna be like this, and then like this, and then that. I'm not sure. I have a feeling it's like tangent somehow, and then we could use tangent to get what we need. Okay, I'm gonna say I have actually no idea how we're supposed to do this. So I'm gonna say tangent of theta is 21 over 29, which means that uh, SOHCAHTOA, so I guess 21 squared plus 29 squared, square root of that, so 21 times 21 is 140, 400, so 441. 29 squared, 81, 360, 400, 841. 441 plus 841 is 1282. 1282. Do any squares end in 2? No, they don't. I genuinely have no idea how to do this, if I'm going to be real, so I'm just going to look at the answer. I get it. Okay, I did not get it right. What I did get correct is stating this, stating this. This was correct, stating this. But in order to find sine, I had to get cosine. I had to use the law of cosines, which then would allow me to get what I need to get. I also saw 841 in there, so clearly that was important. But I had to use the law of cosines to find cosine to find sine. Cool. Thank you guys for watching. I'll see you guys tomorrow. Bye.